Welcome back in the lecture series where we are going to discuss about the introduction to electronics components. This is second part. In the first part we already discussed about the few components that are nothing but your resistor, inductor, capacitors, then LEDs, then LDR. These are the basic components which are going to deal with the electronic circuit. Now we have more components. We can say that actuators, we can say that sensors, as we already discussed about the definition of actuator, which can be which have an electrical input and turn it into the physical action. As we can say that motor, we have electrical input and it will get converted into the form of motion, and then we can say that speaker as an electrical input and convert into the form of sound. So these are the different components which are most important part which when we are going to deal or design electronic circuit. So the first is we can say that DC motor, as we see that the DC motor which have the north pole and the south pole, and that we will apply this inputs to that particular device, and then it can be rotated in clockwise or anti-clockwise direction. So the DC motor is a machine that converts direct current, DC direct current, into the electrical energy into the rotary mechanical energy. As we know that the direct current is a DC current, so we will apply the input as an a DC, and their output is in the form of mechanical energy. Rotary mechanical energy means rotor will get rotate either in the clockwise or in the anti-clockwise direction. So we can provide that particular motion is in the form of direction in clockwise or anti-clockwise through DC motor itself. So that's why it is called as a DC motor. Second, we can say that the stepper motor, as we know that the steps, like the stepper motor is a DC motor that divides a full rotation into the number of equal steps. That equal steps, as we say that the steps it will get rotated in the form of steps to by an angle. So that basically the angle is 1.8 degree. So the stepper motor converts a train of input pulses into the precisely defined increment in the shaft position. So we can say that the shaft is an outer portion. If we'll touch that particular shaft during the on condition, we can say observe the sense the steps of that particular motor. The shaft will get move in the form of steps. Each pulse moves the shaft through the fixed angle. That angle is 1.8 degree. So that we are very much aware about that. The stepper motor, that the motor position can be commanded to move and hold at one of these steps. So we can control that particular motor. DC motor will get directly motion, that completely movement in the clockwise or anti-clockwise direction, but the stepper motor will get have a steps. So we can stop that particular steps and we can observe that particular motion and we can hold that particular point. The motion motor will get hold at particular point. So that this is a basic definition of stepper motor. About the servo motor, we can see here the types of the servo motor or the images of the servo motor. The servo motor is a motor coupled with the sensor for position feedback. We can take a position by an angle 30 degree, 40 degree, 90 degree. So these are the total 160 degree movements is there. So we can say that see the shaft, black color shaft, or that particular white color shaft is here. So whenever we apply the particular signal to this particular motor, electrical signals, then that particular shaft will get moved in particularly by an angle. The servo motor allows a precise control of angular or linear position, velocity, and acceleration is a basic application or the particularly characteristics of the servo motor. Servo motor are used in applications such as robotics, automated manufacturing unit, and so many other applications are there by using the servo motor. So this is about the servo motor, which is most important. So as we know that this motor or these particular signals will get control, and that we require a relay as an out in between that particular signal and the motor. We cannot directly connect that motor to the particular any supply, or we cannot directly connect that motor to the processor itself. So we require a driver circuit, or sometimes for particularly to on and off the particular condition of the light or bulb, we require a relay. So what exactly it mean by relay? We can see the image or the circuit diagram of the relay. The relay is an electrically operated switch that open or close when power is applied. When the power is applied, then it depends on the situation or the condition and the connection. So it will get normally closed and normally open. So the inside a relay is an electromagnet which controls a mechanical switch. So mechanical switch, the tuning, that particular, we can see here the spring. So whenever the supply is given, then that switch will get connect, or it will get open. So on the basis of that, the output will get work, or the output will get function. So this is a simple definition of a relay. We have a motion sensor. It is also called as a PIR sensor, passive infrared sensor. The motion sensor is a device that detect the moving object, particularly people. Though that can be, we are very much about that IR sensor and the PIR sensor. IR sensor is an infrared sensor, and the PIR sensor is a passive infrared sensor. The passive infrared sensor, the motion sensor, is also called as motion sensor, is a device that detect the moving object, particularly people. Such a device is often used to automatically perform a task or alert a user of motion in an area in which the sensor is mounted. So if we know that about the jewelry shop, if the jewelry shop will get closed, and if there is any people or any person will get, or the object will get moved inside that jewelry shop after the closing of that jewelry shop, then that the notification and the other information can like send it to the owner of, or the shopkeeper of that particular, or the guard of that particular shop, so that can be given that alert. So some people or someone is there inside that particular jewelry shop. So this is one of the application of motion sensor. It is also called as a PIR sensor. Next is the electronics, the component is a buzzer. As we know that the buzzer, or we can say that the, like, it will generate a beep. The buzzer is an electrical device that makes a buzzing noise and is used for signaling. So if there is, as we already told you about that, the jewelry shop, example of jewelry shop, and if there is any person inside this particular jewelry shop after closing that jewelry shop, so that we can connect a buzzer at the output, or it will indicate that the buzzer will get indicated as an output and connected as an output, and indicate that some people or someone is there inside that particular jewelry shop. So the buzzer can be mechanical, electromechanical, mechanical or electromechanical, or piezoelectric device. So it will generate the beep or buzzing noise to indicate that like some sort of like notification or the information as an output. So this is a simple example of buzzer. So as we know that we have actuator, DC motor, servo motor, stepper motor, and we also have a relay, also have a buzzer. So these are the components. We have a motion sensor. These are the components which are mostly important for designing a electronic circuit. So these are basic devices. Now we can go for the activity how to connect that particular devices, and how to design a simple circuit. We cannot go for the processor or the any other hardware. We can just go through the battery and these devices, how to connect and how to get the output. So in the next lecture we are going to deal with this particular activity. So thank you very much. If you like this lecture, please like and subscribe my video channel. Thank you.